So you had two vocabulary words when you walked in, compound inequality and interval notation. Compound inequalities, it's kind of like what it sounds like, it's more than one inequality in one. There are two different types, intersection and union. An intersection is kind of like how it sounds, where they connect. And a union is where they're away from each other. So the two different types are up here. So an intersection uses the word and, or it has no words at all, okay? All numbers that are solutions to both inequalities, so it's in its connection, they go together. You'll see that on the next slide. A union uses the word or, and it puts both solutions to inequality. It makes one large solution. And you'll see here that an intersection, we have the variable in the middle, and then we have our inequality sign here. So this is x is greater than or equal to 2. So if you look here, it's a closed circle, and x is greater than or equal to 2. But also x is less than or equal to 7. So again, a closed circle, and it's less than or equal to 7. And it's all the values in between. Okay? So this is like one of the only times in which you're not looking at the direction that the arrow is pointing to see which direction it's going, because technically this is x is greater than or equal to 2. So it would look, if this was by itself, it would be x is greater than or equal to 2. So then yes, it is pointing in the right direction. Does that make sense? But we don't write these as separate problems though. It's one problem. Okay? And a union, it has an or in it. So x is less than 7, so an open circle at 7, it's less than 7. Or x is greater than or equal to 11, so it's greater than or equal to, so it's a closed, and then it's greater than 11, so it goes to the right. So solving compound inequalities, so we're looking for the for intersections, we get the variable in the middle by itself. So whatever we do to the middle, we must do to both ends of our inequality, and then we graph the solution. Unions, we solve each inequality separately, just like we've been doing for the last few days of solving inequalities, and then we graph the solution. So if I were looking at just this, I'd have to add 8, right, to solve this equation? So I'm going to add 8. But whatever I do to the middle, I have to do to both sides of my inequality. So I'm going to add 8 and add 8. Okay? So negative 2 plus 8 is 6. And 10 plus 8 is 18. I haven't divided or multiplied by any negative numbers, so my inequality signs stay the same. And then I have left over was 3x. So then I'm going to divide by 3. Whatever I do to the middle, I have to do to both ends. So again, I'm dividing by positive numbers, so my inequality signs are going to stay the same. So 6 divided by 3 is 2, and 18 divided by 3 is 6. And my 3's cancel out, leaving me with x. And that's the goal, is to get x in the middle by itself. So this is like x is greater than or equal to 2, but less than 6. So on my number line, x is greater than or equal to 2. So that means this is going to be a closed circle at 2, but x is greater than or equal to 2. So it's going to go in that direction. But x is less than 6. That's an open circle, and it's less than. Next. So this one has an or, so that means that's a union. So that means I'm going to be solving each inequality separately. So I'm going to subtract 3 from both sides. So I'll get 2x is less than 2. And I'm going to divide by 2. Am I divided by a negative number? No, so I'm going to keep my inequality sign. So x is less than 1. I'm going to do the same thing here. I'm going to add 7 to both sides. So 4x is greater than 16. Divide by 4. I'm dividing by a positive number, so I'm going to keep my sign the same. And then 4. So then I draw my number line. So x is less than 1, so at 1 it's going to be an open circle and it's less than. But x is greater than 4, so open circle greater than 4. Okay, this one doesn't have an or, so that means it's going to be an intersection, so I'm gonna solve it together. So I need to get x by itself, so I'm gonna add 2. Whatever I do to the middle, I have to do to both sides. So I'm gonna get 0 is less than negative x, which is less than 3. Okay, is x by itself yet? No, there's a negative 1 in front of it, so I need to divide by negative 1. And what happens when I divide by a negative number? I flip the signs. This is something that we did that's new. So when you're dividing by a negative number and you have an inequality, you're going to change your sign. So this, instead of this being less than, it's become greater than. Instead of this being less than, it's become greater than. So 0 divided by negative 1 is still 0. And 3 divided by negative 1 is going to be negative 3. So I'm going to draw my number line. And at 0, it's going to be an open circle, and x is less than 0. So that means it's going to go in this direction. But x is greater than negative 3. So that's going to be open circle and greater than. We could rewrite this as negative 3, and then the x is greater than and less than 0, because then it would go in the order in which we are doing it. Yeah. If it has an equal to sign, it's a closed circle. If it doesn't have the equal to sign, it's an open circle. And that's also something that we learned when you were out. But you can look, I printed off the worked out versions of those notes for you. All right, so this has an or, so I must solve them separately. So I'm going to subtract 5 from both sides. So I'll get negative 3x, and then that will be 8 minus 5 is 3. I'm going to divide by negative 3. So I'm dividing by a negative number, so I'm going to flip my sign. So then x is going to be less than negative 1. Here I'm going to be dividing by negative 1. So again, I'm going to flip my sign, greater than or equal to. So x is going to be greater than or equal to 4. So drawing my number line. So we have an open circle at negative 1, and it's less than, so it's going in that direction. And then a closed circle at 4, and it's greater than, so it's going in that direction. So our next one, we have a fraction, and how do we get rid of a fraction? And what do I least common denominator in this case? Okay, so I'm going to multiply everything by 4. So 4 times negative 3 is going to give me a negative 12, less than or equal to. My 4's here cancel out, leaving me with x minus 5. And 4 times 4 is 16. I'd add 5 to both sides, or all sides. So then I'm going to get negative 7 is less than or equal to x, which is less than or equal to 21. Draw our number line. So negative 14, negative 7, 0, 7, 14, 21, 28. Going by 7s. So I'm going to have an open or a closed circle at negative 7. Close, because that's an equal to. And so x is greater than or equal to negative 7, so it's going to go in that direction. But x is less than or equal to 21. Again, it's a closed circle. And it has an intersection, so it's everything that's in between here. Right. In 1967, a 30-second commercial during the Super Bowl cost $85,000. In 1998, the cost rose to $2.6 million. Write a compound inequality that will represent the different prices of the commercials. So we're looking for all prices of the commercials from 1967 to 1998. So my X has to be greater than or equal to my lowest amount, which was $85,000. But less than or equal to our largest amount, $2.6 million. And that's it. It's already solved. What?
That's a lot of money
Mhm.
for a second.
Mhm. And that was 20 years ago. Probably
Like 20 times
more
more.
than that.
That's too much. Way too much. Still.
You want everyone to just the sort of like does anyone really watch them?
Exactly.
So which one you're?
That's the only reason why I watch the Super Bowl is to watch the commercials. I don't like football.
I watched the Puppy Bowl.
Alright. Interval notation is a shortened way to write an interval represented by a number line. So this is a shortened way to write inequalities, okay? And we use special symbols. So if it is a less than or a greater than symbol, we're going to use parentheses. If it's a greater than or less, or greater than or equal to, or less than or equal to, we're going to use brackets. If it goes on forever in the positive direction, we're going to have a positive infinity. If it goes on forever in the negative direction, we're going to have a negative infinity. Okay, so for example here, this one is x is greater than or equal to 2. So at 2, I have a closed circle, so that means I'm going to have a 2. And then it's going to be a bracket because it has a closed circle, and that means it's equal to. And then it goes to positive infinity, and then always the infinities just have a parenthesis. Okay? So, write an interval notation. So this is an open circle, so that means it's going to be a greater than or not equal to, so it means it's going to have a parenthesis, and then we have a negative 2. And it goes to 5, and it's a closed circle, so it's going to be a bracket.
Okay.
And this would be like the same as negative 2x is greater than negative 2, but less than or equal to 5. But instead of having to write all of this, you can write it just like this. Okay, that's why it's a shortened version. So this would be the same as x is less than 7, right? And this would be the same thing as x is greater than or equal to 11. But instead of writing like that, we're going to write it as 2 separate intervals. This goes to negative infinity. So I'm going to do a negative sign and then an infinity, and it gets a parenthesis. And then it's open, so that's also going to get a parenthesis. And then it's going to be an or. And then 11 is a closed dot, so it's going to be a bracket. And then it goes to positive infinity. It's a parenthesis. Okay, this one's asking us to graph. So am I gonna have an open or a closed circle at 2? Closed, because it has a bracket, and it's gonna go towards negative infinity. Am I gonna have an open or a closed circle at 4? Open, because it's a parenthesis, and it's gonna go towards positive infinity. Okay, am I gonna have an open or a closed circle at -1? Closed, because it's a bracket. Open or closed circle at 0? Open, and because it's only one thing, it's going to be a intersection. Can't think, brain dead.